The question we are solving now belongs to test series 11. It is of signals and system subject. In specific, it belongs to frequency representation of signals. Please note that this is a common data question. As per the question, there is a discrete time signal which is given as x of n is equal to minus j comma minus j comma 0 comma 2 comma minus 3 comma 0 comma 0 comma 1. The first minus j corresponds to the instant n is equal to 0. It is given that x of k is dft of x of n and x of e power j omega is dtft of x of n. We need to find the values of sigma k equal to 0 to 7 abs of x of k whole square and x of 4. We know that by the analysis equation of DFT, x of k is given as sigma n equal to 0 to n minus 1 x of n multiplied by e power minus j 2 pi by n kn, where n is the length of the signal which is equal to 8. So from this we can say that upon substituting k is equal to 4, x of k 4 is equal to sigma n equal to 0 to 7 x of n multiplied by e power minus j 2 pi by n kn. Upon simplification, 2 pi by n kn can be written as 2 pi by 8 multiplied by k multiplied by 4. So this finally can be simplified as k pi. So we can write that x of 4 is equal to sigma n equal to 0 to 7 x of n e power minus jk pi. Sorry, this is n4, so this will become n pi. So now upon expanding this equation, we see that this can be written as x of 0 plus x of 1 multiplied by e power minus j pi plus and so on till x of 7 multiplied by e power minus j7 pi. And this upon simplification becomes minus 6. Now by Parseval's theorem, we know that sigma n equal to 0 to n minus 1 abs of x of n whole square is equal to 1 by n multiplied by sigma k equal to 0 to n minus 1 abs of x of k whole square. So from this we can say that sigma k equal to 0 to n minus 1 abs of x of k whole square, which is the quantity we need to find out, is equal to capital N times sigma n equal to 0 to n minus 1 abs of x of n whole square. And upon substituting the relevant quantities, we see that this can be simplified as 8 times abs of x of 0 square plus abs of x of 1 whole square plus and so on till abs of x of 7 whole square. This upon simplification becomes 8 multiplied by 1 plus 1 plus 4 plus 9 plus 1, and this can finally be written as 128. From this we can say that the quantities that we need to find out, that is x of 4 is equal to minus 6 and sigma n k equal to 0 to n minus 1 abs of x of k whole square is equal to 128. Hence the correct option which corresponds to the required values is B.